Pascal's triangle then. Pascal's triangle is a number pattern named after Blaise Pascal, a famous French mathematician and philosopher. It will help us to expand binomials without doing the long multiplication of polynomials. Really, you only have to memorize one part of it. You have to memorize the fact that ones go down the outside of the pyramid on both sides. Okay, ones will go down both outside diagonals of the pyramid, or the triangle. Okay, if you can remember that, the rest is just addition. To get this box, you look at the two that are above it. See how that box and that box are above it? What's 1 plus 1? 2. So to get this box, you look above it. 1 plus 2 is 3. So this would be a 3 as well, because above it are a 2 and a 1. Okay, I'll stop for a second so people can write and then have time to look up. Okay, so this would need to be a 4, because above it is a 1 and a 3. Now, you'll start to notice some symmetry. This is a 4, and so is this one over here. This is a 6. This would be a 5, then 10. Oops, my bad. 10, another 10, and then another 5. Okay, there's also some patterns, okay? Now, I don't want you to focus on trying to remember the patterns because it's easier just to add. But look right here. 1, 2, 3, 4, 5. So this will be 6, 7, 8, 9, 10, 11. Okay, same thing over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, also look at this pattern. From 1 to 3 is an increase of 2. From 3 to 6 is an increase of 3. That's an increase of 4, so our next increase is going to be of 5, which would make this a 15. If the next increase is of 6, that would make it a 21. That would make this a 28. But see how it's almost easier, instead of trying to do it like that, to just add? Okay, so I want you to complete the triangle. Okay. Okay, we're going to expand each power. Now, I'm going to get rid of the lines just because I don't like them there. I'd rather just have blank space. Pay attention, guys. Today's not the day to mess around. A plus B squared. What does that mean? Right, it's being multiplied by itself. It literally means there's 2 A plus B's, right? Well, when you see something like that, what do you know to do to it? Multiply by what method? FOIL. Okay, so you would multiply the first number in each one, which is an A and an A, right? And that would give you a squared. Then you would multiply the outer terms, which are A and B, and that makes AB. Then you multiply the inner terms, which are a B and an A. Now, I know most of you are going to want to write BA. However, you need to alphabetize them so that in a minute you realize that they're like terms. If you write this one as AB and this one as BA, you might not recognize that they're like terms, and they are, because both of them are just the product of A and B. So even though, yes, you want to put BA because B came first, always alphabetize the letters. And then B times B is B squared. Now we see that A squared just comes down because it's the only A squared out of all 4 of those terms. We had 2 ABs, right? And then we have a B squared. Now, I want you to notice something. Even though we didn't write in the coefficient, what's the coefficient of A squared? 1. What's the coefficient of B squared? 1. So don't we have a 1, 2, 1? 1, 2, 1. The reason we're using the road 1, 2, 1 is because it was raised to the second power to begin with. Okay, so now let's look at B. Shh, pay attention. What does A plus B cubed mean? Right, A plus B times A plus B times A plus B. Well, don't we already know if we took two of these and FOILed them, we would get this? Because we just did that. So I can go ahead and know that A plus B times A plus B is A squared plus 2AB plus B squared, right? Everybody following? But then I haven't dealt with this third binomial of A plus B. Think back to what you did yesterday. Okay, remember yesterday we had a problem like this, a binomial times a trinomial? Didn't we just start out by distributing the x to everything over there, and then we distributed the 3 to everything over there, and then we combined like terms? Well, that's what we're about to do. We're going to start with the a. We're going to distribute it to everything. A times a squared is a cubed. A times 2ab. Think about what you've got there. Between the two things, you have a 2, you have an a times an a, which will make an a squared, and you have a b. So 2a squared b. Okay, let me say that again because I know that's a little tricky. When you're multiplying an a times a 2ab, we have a 2, so I wrote that. We have 2 a's, which make an a squared when you multiply them, and then we have a b. Now I need to multiply a times b squared. What do you think a times b squared is going to be? ab squared. Okay, now that I've distributed the a to everything, I'm finished with it. And now I need to do what, Cameron? What? Is that all 65? Okay, thank you. Distribute the b to everything. What do you think b times a squared is? Well, a squared b. The a is squared, so it would be a squared b. Well, isn't there already an a squared b right there? So I'll just write it right below it. And isn't that a 1a squared b? Okay, what is b times 2ab? 2ab squared. And then what is b times b squared? B cubed. And there's no other b cubed, so you just write it separately. Okay, so now a cubed is the only term of its kind. There's no other just regular a cubed, so it just drops down. We have a total of 3 a squared b terms, right? We also have a total of 3 a b squared terms, and then we have 1 b cubed. Now, I didn't write the coefficients, but isn't there a coefficient of 1 there and a 1 there? Look, 1, 3, 3, 1. If you look at your triangle, 1, 3, 3, 1. Okay, but that's a lot of hard work, right? We're about to learn how to use that triangle to make this process much easier, where you don't have to do all of that foiling and distributing, okay? So you're about to realize the point of Pascal's triangle is to avoid what we just did. So let's go to the next page. Are there any questions so far? Shh. Pay attention. Pay attention. Here's how the pattern works. You go to Pascal's triangle to the row that matches the exponent. What is the exponent here in this problem? 3. So you need to go to the triangle and go to the row where you first see a 3, which would be this row, right? 1, 3, 3, 1. That means I'm going to be using the row 1, 3, 3, 1 because it had an exponent of 3. Now, what those numbers are, pay attention. Those numbers are your coefficients. So 1 is going to be the coefficient of the first term, 3 is going to be the coefficient of the second term, another 3 is going to be the coefficient of the third term, and 1 is going to be the coefficient of the fourth term. Okay, the next thing you're going to do is you're going to bring down the terms that are inside the parentheses. You list them in order, x, y, on every term. You have to list them in the order they were given to you. Okay, now, since x was first in the binomial, it gets to start out being cubed. Okay, so look up here so you don't get lost. Since x was first, it gets to be cubed first. But then from there, it decreases. X cubed, x squared, x to the first, x to the 0. Now, y is the opposite. It wasn't first, so it starts out the opposite. It starts out with 0 and increases. Now, one thing that you'll notice about each term is that its exponents add up to the overall exponent of 3. Look, 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. Okay, your exponents in each term will always add up to your exponent from the question. Otherwise, you've done something wrong. Now from here, you just simplify. And what I mean by that is there really a need to write a coefficient of 1? No. So I would write x cubed. What is y to the 0 power equal? 1. Remember we learned a month or so ago that anything raised to the 0 power equals 1. So is there any need to write that? No. So I'm done with term 1. Term 1 is x cubed. Okay, term 2. It's a 3, so yes, there's a need to write it. X squared can come down, but then when I bring down y to the first, I don't need to write to the first. I can just write y. So basically all I'm doing in this step is rewriting this, but not rewriting what's understood, like the coefficients of 1, the exponents of 1, or anything raised to the 0 power, because they're 1s. I'm just rewriting it, but I'm not writing down the stuff that's understood. Does that make sense? Okay, so I'm done with term 2. Now let's look at term 3. I bring down the 3. I bring down the x, but I don't need to bring down the first power. It's understood. But then I do need to bring down the y squared. So I'm done with term 3. Now with term 4, 1 is understood. X to the 0 power also equals 1. So all I need to bring down is a y cubed. And then that's my final answer. Now I want you to keep in mind that this was x plus y cubed. And look at our answer. X cubed plus 3x squared y plus 3xy squared plus y cubed. Look what happened a while ago when we had a plus b cubed. It did the same thing, except for instead of x's and y's, it's a's and b's. But wasn't it a lot harder to do it this way? A lot more work? I mean, I know what you're thinking now. You're thinking this is just as hard, but once you get the hang of it, it's a lot easier than doing all of the FOIL and distributing. Okay, so let's try another one. This time we have c plus d raised to the 4th power. Since it's to the 4th power, we need to go to our triangle. And which row do we go to? Oops. We go to the row that starts with 1, 4. Okay, so we're looking at this row. 1, 4, 6, 4, 1. Okay, so write down those numbers on this line. 1, 4, 6, 4, 1. What are those numbers? The coefficients of each term, right? So 1 is the coefficient of the first term, 4 is the coefficient of the second term, 6 is the coefficient of the third term, and then 4 and 1. Those are your coefficients of each of your terms. Now, our two things that are being added are c and d. So you bring each of those down. Okay, since c came first in the binomial, it gets to be raised to the 4th first. Okay? But then from there, it descends. You would cube it next, then square it, then raise it to the first, and then raise it to the 0. Okay, the d will just do the opposite. It starts out to the 0 power and then moves up to the 4th power. Because remember, each term's exponents must add up to 4 in this question. 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and 0 plus 4 is 4. Everybody with me still? Now I'm ready to simplify. So like when I'm looking at term 1, what does not need to be brought down out of term 1? The 1 doesn't need to be brought down? Or the d to the 0, because it also equals 1. So the only thing I need to bring down from the first term is that c to the 4th power. Okay, so I'm done with term 1. Term 2, what all needs to be brought down? The 4 and the c cubed. d, but you don't have to write to the first power. That's understood. Okay, what needs to be brought down out of the third term? Right, everything had to be brought down that time because nothing up there would be understood if you left it off, right? Okay, what about the fourth term? Right, I didn't need to bring down the 1, it's understood on the C, but everything else had to come down. And what about the fifth term? Just the d to the fourth needs to come down because 1 is understood as a coefficient and c to the 0 is also a 1. So you're done. That's the answer. Now, the only other way to get that answer would have been to take c plus d and multiply it by c plus d and multiply it by c plus d and multiply it by c plus d again. And that would be a lot of work, right? Because you would first have to FOIL those two, and it would produce a trinomial. Then you would have to FOIL those two, it would produce a trinomial. And then you would have to distribute the trinomial times the trinomial. And remember from your homework and classwork yesterday, doing a trinomial times a trinomial is a lot of work, right? And keep in mind, before you can even do that, you've already had to FOIL two different places. So that would be a lot of work to do it that way. That's why we have Pascal's triangle. Are y'all ready to try one on your own? Just give it a shot. It's not going to hurt you if you get it wrong. Just try it and then I'll go over it. So, since it's raised to the fifth power, you look to the triangle, and that means we need to use this row. 1, 5, 10, 10, 5, 1. Okay, so 1, 5, 10, 10, 5, 1. Those are my coefficients of each term. Since A is added to B, you're going to bring down an A and a B in each one. Okay? A is first, so it gets to start out being raised to the fifth power. But then it descends. It goes to the fourth power, third power, second power, first power, 0 power. B does the opposite. Because remember, they have to add up to 5. So it has to start out at 0, then 1 to make 4 and 1 to 5, then 2, 3, 4, 5. From there, you just simplify, which means basically rewrite it, but don't write what's understood. So what's the only thing I need to rewrite out of this first term? The a to the fifth. Plus, what do I need to rewrite from the second term? Right. No need to write that 1. It's understood. Okay, what about the third term? All of it. Everything has to be rewritten. Nothing would be understood. The next term. All of it again. Okay, the next term. No, you don't have to write that 1. So 5a, b to the fourth. And then the last term, just b to the fifth. Now, have y'all noticed a pattern about how many terms you end up with? Let's look back up to the first one. Whenever it was raised to the third power, we ended up with how many terms in our answer? 4. Whenever it was raised to the fourth power, we ended up with 1, 2, 3, 4, 5 terms. When it was raised to the fifth power, we ended up with 1, 2, 3, 4, 5, 6 terms. So how many terms do you think you're going to end up with when it's raised to the sixth power? 7. You always end up with one extra term like over the exponent's number. Okay? So go ahead and try f plus e to the 6th. F plus e to the 6th power. Since it's to the 6th power, I look at the triangle and I go with this row. The first one I find is 6 in. So 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. Those are my coefficients of the terms. Now for each one, I put an F and an E. Okay? F gets to start out to the what power? 6. and then from there it decreases all the way down to the 0 power. E does the opposite. It starts out to the 0 and increases up to the 6th power. Because remember, within each term, the exponents must add up to your exponent of the problem. Now I just rewrite all that without writing the stuff that's understood. So for this first term, what would I need to rewrite? Just the f to the 6th. What about for the second term? Right? Third term? Right? Fourth term? All of it. Fifth term? Sixth term? Right? And seventh term. Just the e to the 6th, because that's a 1. Right, f to the 0 equals 1, so you don't have to write it. Now, keep in mind, guys, that once you learn the fact that you're going to have one term higher than the exponent, don't you think that could help you eliminate some wrong answers on a test just by looking at the number of terms in the answer? There is no homework. Monday we're going to continue and we're going to start trying it with numbers. Okay, you can switch out, but I need some help.